signaling molecules and growth factors, which can effectively contribute to the regulation of both immune and inflammatory response. So the mechanism, we'll go to mechanism of mesenchymal stem cell mediated immune modulation. So although there are underlying mechanism which is not still understood, but some of the suggested mechanism is it can be mediated by either soluble factors or cell to cell contact dependent mechanism. So these mesenchymal stem cells, they regulate by adaptive and immune stem cells by the suppression of T cells and maturation of the dendritic cells, by reducing the B cell activation and proliferation. So they promote generation of T regulatory cells via soluble factors and cell to cell contact mechanism. First we go to immunomodulation by the soluble factors. So there are various soluble factors have been proposed to mediate the immunosuppressive effect, including transforming growth factor, prostaglandin, hepatocyte growth factor, IDO, which is the indoleamine pyrrole 2,3 dioxygenase, nitric oxide, and IL-10, interleukin 10. So these pro-inflammatory cytokine, which includes interferon, IFN, gamma, also with a combination of tumor necrosis factor, then IL alpha and IL beta, they have various potential to induce the mesenchymal stem cells to secrete various enzymes and soluble factors such as cyclooxygenase, PGE2, and IDO that mediate the immunosuppressive activity. So where the PGE2 are dramatically, they are upregulated after a co-culture of mesenchymal stem cells with the peripheral blood mononuclear cells. So they have the ability to inhibit the T cell proliferation. Again, the IDO, by catalyzing the conversion of tryptophan to chironeurin, they have the ability to inhibit the growth and function of immune cells. So the secretion of IDO by the mesenchymal stem cells, they have shown to inhibit the allogenic T cell responses. That induces the kidney allograft tolerance. Although this IDO expressing dendritic cells have been shown to mediate the inhibitory effect of the mesenchymal stem cells on the T cell proliferation. Again, one more soluble factor is the NO. NO soluble factor, they are known to inhibit the T cell proliferation. So it has been shown that mesenchymal stem cells produced NO factor is one of the major mediators in the T cell suppression by the mesenchymal stem cells. So the effect of these soluble factors on the activity of the mesenchymal stem cells may vary depending on the origin of the mesenchymal stem cells that target the cells and the microenvironment. So also mesenchymal stem cell therapy, they contribute immunosuppression, and further elucidation of these detailed biological mechanisms involved in the process is required. At the same time, it must be noted that some cytokines or chemokines released from the mesenchymal stem cells that can be harmful, that is tumor necrotizing factor 6 and IL-6 that promote an inflammatory response. So therefore, regulation mechanism of mesenchymal stem cells to produce a beneficial soluble factors and how such factors can modulate the immune cells are the key issues that underlie the successful immunomodulation effects of the mesenchymal stem cells. So the first we saw the soluble immunomodulation by the soluble factors. The second one is the immunomodulation by cell to cell contact. So culture systems have shown that cell to cell contact is a key factor involved in the immunomodulatory effects in the mesenchymal stem cells. So direct mesenchymal stem cell T cell therapy, T cell contact is necessary for the induction of the TREX, that is the regulatory factors. So these mesenchymal stem cells, they secrete cell adhesion molecules such as CD274, which is the programmed cell death ligand 1. So and then vascular cell adhesion molecule 1 and galectin 1. So these are upregulated by IFN gamma that enhances the cell to cell contact and the mesenchymal stem cell cells, they influence the macrophage differentiation and polarization by secreting the PGE2, IDO, interleukin 10 and the transforming growth factor beta. They promote anti-inflammatory M2 phenotype while inhibiting the pro-inflammatory M1 phenotype. So these mesenchymal stem cell mediated macrophage polarization is facilitated through secretion of the soluble factors, particularly binding with the PGE2 to EP2E4 receptors and with the IDO activity. They regulate the response of TNF alpha and IFN gamma. So this mesenchymal stem cell derived exosome, they serve a crucial mediator of intercellular communication, modulating macrophage polarization by transferring the microRNAs that inhibits the proliferative signaling pathway, thereby promoting the M2 phenotype. So next one is the interaction of mesenchymal stem cells with the adaptive immune cells. So mesenchymal stem cells regulate adaptive immunity through direct contact and the paracrine activity. So which includes T cells and B cells. Mesenchymal stem cells, they suppress the CD4 plus and CD8 plus T cell proliferation, and which induces the apoptosis, and this arrests the T cell activity. Then these mesenchymal stem cells, they inhibit the T cell cytotoxicity in early phases, and also they adhere to T cells via the chemokine and adhesion molecules, which blocks their activation. So also they promote the TREG development via the HLA G5 and other pathways affecting the immune regulation. So they also suppress T helper cells TH70 and T helper cells 1, enhancing the regulatory function with the in vivo activity. And the B cell also it inhibits the B cell proliferation, maturation, antibody production, blocking the B cells in the G0 and G1 phase. It also reduces the B cell chemokine receptor expression and antibody secretion via the PD1 and PDL pathway. So these mediated inhibition of B cells involve interaction with T cells affecting both humoral and cellular immunity. So after this mechanism, so what are the potential challenges of mesenchymal stem cells in immune modulation therapies, sir? Although we have majority of the pilots clinical trials have been done, recipients of mesenchymal stem cell therapy demonstrated good tolerance and improved clinical symptoms. So although these results from this clinical trial indicated that mesenchymal stem cell based therapy is a promising strategy for immune modulation, some of the challenges are there which to overcome. So first one is the they have done in 2009 with prochymal phase 3 graft versus host disease. They have done a trial in 2009 where Osiris Therapeutic reported that in prochymal phase 3 trial of graft versus host disease involving 192 patients, the trial did not show any clinical differences between the treated and the placebo groups. So second one is the inconsistent result in the mesenchymal stem cell based immunomodulatory therapies. So due to various small sample size, variability in the sources of mesenchymal stem cells, preparation methods and delivery approach make comparison between the studies are difficult. The third one is the variability in the mesenchymal stem cell sources and the donor age. So mesenchymal stem cells used for the immunomodulatory therapy, they are derived from various tissues like bone marrow, adipose tissue, which does not match with the donor age. So that one of the limitation of the thing. And then influence of cell dose, cell modification and injection frequency is one of the major disadvantages. And the last one is the mesenchymal transfusion patterns and targeted delivery. So the delivery method is still not supported. So these are the limitations of the immunomodulation therapies by mesenchymal stem cells. So what are the potential clinical applications of this mesenchymal mediated immunomodulation is some of the thing is graft versus host disease. So graft versus host disease is an autoimmune disorder. So they have done a trial and they can be potential, these mesenchymal stem cell based therapy can be used in these diseases, where the graft versus host disease, they arise from the T cell which attacks the post HSCT, and these mesenchymal stem cells, they have the ability to modulate the immune responses, improve the survival, and they inhibit the T cell activity. So clinical trial also shows that mesenchymal stem cell therapy reduces the mortality while preserving them from the tumor effect. So, and then mesenchymal stem cell derived from the bone marrow umbilical cord and other adult stem cells shows the promising results. And next is the systemic lupus erythematosus. This is again other diseases. So, where they are involved in dysregulation of T cells and B cells with elevated pro-inflammatory cytokine. So, these mesenchymal stem cells again they show potential in treating by due to their immunomodulatory properties, and clinical trial shows that they can modulate the immune cells and reduce inflammation. So, the other disease is the chronic Crohn's disease. So, where it is Crohn's disease is marked by T helper cell 1 driven inflammation and high cytokine levels. So, these mesenchymal stem cells have the ability to suppress the inflammation and improve the Treg cell activity, which is a regulatory factor. And clinical trial also shows to lead the symptom relief and clinical remission with the minimum adverse effects. So, autologous or allogenic mesenchymal stem cells are effective particularly in chronic Crohn's disease. So, the